So, making sense of molten plastic. Now, I've been instructed there's a delay. So firstly, who am I? I'm a geek. I say that all the time. You know, it's good to get off my chest, all that sort of stuff. But most of all, I'm essentially a room full of 6-year-old children worth of excitement packed into a relatively calming, I'm not going to try and claim to be quiet. I love to create things, and one of the things I love to do is 3D printing. Now, what do I do on weekends? So, apart from spending time with my lovely girlfriend, I build robotic spiders. Now, I could blither on for hours and hours about the technology enhancements that have allowed me to do this, but the biggest one is 3D printing. So, I have an engineering background from working with my dad. I could grab a CNC lathe and a chunk of billet aluminium and I could make anything. And it would take weeks, and it would take many iterations, and it would cost too much money. 3D printers have enabled me to actually make these precision models of a specific size and iterate them quite rapidly. So to start with today, I'd like to just talk about a bit of the technology behind 3D printing, where consumer 3D printing is at the moment. There's basically two types of consumer 3D printers. There's actually quite a lot more than that, but only two actually exist in the market. And the first one is the Fdm printers. Now, FDM stands for something that is always hard to say in front of people, which is fused deposition modeling. I knew I'd screw it up. It basically turns, you know, solid plastic into liquid plastic and makes it into a situation that ends up as a cool thing. Now, it does that via the use of something called an extruder. Now, in my half-conscious writing of the title of this one, I had some cartoons that were talking about intruders, and it was hilarious, but the title has lost its magic. Essentially, what you've got is you've got a big spool of plastic on one end, you've got a motor that pushes it into something that's really hot, and that really hot thing only has one outcome, which is a nozzle. Now that nozzle draws a pretty little pattern over quite some time, and then it goes up a layer and does it again. It works actually a lot like a hot glue gun, which I'm sure we've all used for, you know, craft shows, sticking shells to bits of cardboard, and, well, I have anyway. Now, after a great deal of time, it produces layer upon layer, and you end up with a really cool product. The little spider that I brought up there is the result of a number of hours that I wouldn't really like to share with myself, let alone everyone else. But yeah, that's essentially the result from an Fdm printer. Now, the good things about a Fdm printer is they're really cheap. So I've got 5 printers now, which is excessive, but you know, each one has a purpose, just like tools in the tool shed. I need a hire. Can everyone hear me now? Okay. They're quite cheap to buy. You can get them from about $400 to several thousand. Recommend not spending several thousand. Ask someone who knows, don't spend several thousand. The materials are really, really cheap. So the stuff that Steve's made out of is about $35 a kilo, and you print it not completely hollow, but mostly hollow. So you can actually do a lot with a kilo. There's heaps of kinds of materials. So everything ranging from your standard plastics that are the same as ABS plastic, which is the same as Lego, all the way through to PLA, which is interestingly made out of some sort of cornstarch product. And you can also get infused products. So I have some at home that's infused with some sort of, I'm guessing, semi-radioactive material that'll glow in the dark, which is great. I made a wee trophy for Ben out of the glow-in-the-dark one. Made a bright one for Rick out of yellow. You can also get materials that conduct electricity, which is really cool if you're building your own sensors. Now, the not-so-good part is they're really slow. So a part the size of a cigarette packet will take you about 6 hours to print if you're doing it in high quality, which can be very tiring, as much as it's hypnotic watching the thing moving. They're pretty noisy, so I have mine in the lounge, close the door, still hear it when I'm trying to sleep. They're very prone to errors. I've had many parts get almost right to the end, and then the extruder comes along and picks up the whole part and throws it into the side and starts making something that looks a lot like a bird's nest. And there's lots of parts to replace. Because it's a very mechanical thing, you've got X, Y, and Z drive motors. They're all got a lot of force involved and a lot of speed. They can break themselves. Now, the next technology I want to talk about is SLA. So I've actually completely forgotten what SLA stands for, and for some reason it doesn't stick in my head. But basically, you're using a light to set liquid resin into solid resin. Now, I was going to have a big diagram about how they work, but they're actually very simple. You basically got a projector at the top, and it shines, a projector on the side, and it shines onto a print surface that periodically dips into a pile of liquid. And the ultraviolet coming from the projection actually makes the stuff hard. Now, this actually was the first kind of 3D printer in the 70s and 80s. Used to be done with slides and OHPs. I might be sharing my age here, if people don't know what an OHP is. It's now gone to the point where they actually use data projectors, and they are very cool. The cool thing about them is they're very fast compared to FDM. They're quiet, they're really accurate for small stuff, and they're quite simple to replace parts. And you don't actually replace parts that often because there's not a lot of sort of violence going on. The problem is that they're a lot more expensive than FDM printers, so they're not quite as accessible. I just parted with $6,000 for one, and my wallet is still poking me. The one downside to them that is actually a problem is because they use a projection area, which is of finite pixels. As you can probably see from here, you can see the edges of the letters. The bigger you make it, the bigger that projection area has to cover. So therefore, the bigger the model, the less detail you can get out of it, or the more blocky square edges, which I kind of think looks pretty cool. And there's limited materials. You can get flexible stuff, you can get solid stuff, and a few colors, and that's about it. So, one of the problems with 3D printing is hard. So it takes a while. It's really easy to fail for any reason. Normally the organic component, the amount of models I've broken myself has been pretty awesome. Has a high error rate because you're dealing with kind of chaotic forces. So you got hot printing bits, you've got motors moving stuff in all sorts of directions, and the modeling is really hard. Now, probably not shown it in all its glory, but I'm very proud of this model. If people want to see what I've actually printed, it's over there, and it's very difficult. I'll show people later. Just a quick skip on to commercial 3D printing tech. Now, when it comes to the materials, the consumer grade stuff is actually miles ahead of the commercial gear, because you've got people like me who are obsessed and want to melt down Coke bottles and print those. But according to the mechanical side of things, the printers in the commercial space are amazing. They're doing things with laser beams, which is one of my favorite things. Basically, you've got cross-sectional lasers forming a really hot spot, and you throw material into the middle of it, and that material could be plastic, it could be titanium. Can you imagine my robotic spider's made of titanium? Goosebumps. They're really, really cool, and if you want to buy one, they're really cheap, going for about $600,000. So, a couple of years away. But that will be my 8th printer. I'm not sure what the 6th and 7th will be, but I will either make one or buy one. And that's called sintering, believe it or not. Now, I've just summarized a few other techs in here. I started searching for commercial tech when I knew that I was going to come and talk to you guys today, and I thought there was about 20 things. Turns out there's thousands. One of the most interesting ones I saw was you can go to Officeworks and you can get them to print you a mini-me, which is, they're ridiculously expensive, but it's very cool. And they actually print it with paper. It works, they call it like a paper jet or something. It hurtles paper at a certain spot somehow accurately, and then it hurtles using something like a bubble jet printer, ink at it. So you can literally have a color version of you that's, depending on how much you want to part with, either this tall or this tall. It's very cool. In China, they're now producing houses. They'll actually print them, these massive crane-driven print machines that work a bit like the Fdm printer I was talking about at the beginning. Pushes like concrete or aggregates or plastic, or I think they're using a lot of polystyrene for insulation, and it can actually print a whole house. And they're saying it'll print it in an hour, which is possibly a little bit overconfident, but still, it's amazing. The amount of things you can do when your formwork is, aggregates that are millimeters large compared to a brick. NASA had a competition, I think it was late last year, where they challenged people to make a new machine for food in space. And this crazy guy from, I think it was Texas actually, managed to build a 3D printer that could print pizza. And you can see the advantages, because you just get basically bags of goo, chuck them on a spaceship and throw them up. You don't have to have complete pizzas. I thought that was excellent. I'd love one of those myself. And the next one I saw that I really like the look of is these concrete art-based printers. So they're they're the same kind of idea as the ones that print houses, but they're much finer detail. So people are making artistic, colorized concrete pieces. The company that made that piece in particular has got the record for the biggest one in the States, which is 18 yards tall, and I'm not 100% sure how big a yard is, but, you know, metric system. But they're amazing. And the amount of detail that they can get out of them, the strength, and when you throw a chunk of concrete that's got a bit of color in it in the sun, it's really cool. Moving a little bit on. This is a part that I get really excited about. I had to stop at like 6, 7 slides because I ended up with about 40. I thought I'd start with stuff that's actually really applicable to what people are going to use in the consumer market. And that, of course, starts with the Fdm printing, because they're the most accessible printers. Now, this company called Mosaic, I'm pretty sure, I think the machine's actually called Mosaic, actually takes multiple kinds of like feeds of plastic and mixes it on the fly as you go, because which solves a problem that I probably haven't outlined, but you can't actually print in multiple colors really. Like, you can use multiple extruder printers, which I've got one. They're really not great. Not for multicolor anyway. But this actually feeds in all of these materials at once, and it can be different kinds of material. You can mix in some glow-in-the-dark stuff, some metal stuff, and you can print them all in one go on a normal printer that's only got one hot end, which is cool, because one hot end's good, because there's less to go wrong. The next one I'd quite like to look, that I really like the look of, is this thing called the Mark I. Now, a few people are actually making this, and basically it's a nylon printer, and that's pretty cool, but it's not necessarily out there, except it feeds a fiber strand as it goes. So one of the problems with 3D printing is that because you're melting layers together, you end up creating a weak point. There's actually a name given to the glassy surface. I don't know if you've ever stuck two lots of glue together that's set at different times. I know I have. But there's actually like a glassy mirror finish between them, and that's a weak point because it's not completely bonded. This printer, because it has the fiber, it actually makes all of the layers fuse together. You can make them thinner, and yeah, they're really, really strong. So one of the things they're promoting this for is for doing things like advanced gearing. The part that's on the I keep pointing at that screen, but I should be pointing at that one. The part that's on there is actually a gear for a turbine. So that's really cool. Now, the next one, I've actually had a bunch of people point this to me. Rick was one of them. This is called the Olo. This is SLA, so it uses light. It's crazy. You sit the box on top of your cell phone, and you open up their specially crafted app, and it shines a light on the material, and this little thing goes up and down. And you can end up with a really, really high resolution print that is basically the size of your phone, but a bit taller, obviously, quite a bit taller. Now, what's really cool about these is they're super cheap. Everyone's got a bloody smartphone, and most people have the flagship Android phones or the iPhones, and they're insanely high resolution. This printer will actually have better resolution than all of the SLA tech that's out now. Of course, your parts will be small. But to be fair, all of the parts on that Spider would fit into that printer. Now, the next one that I'm really excited about takes a bit of a weird way to explain. So most of the printers, the SLA printers, they've got a board that they dunk in plastic and then they shine light on, like I was talking about before. The problem with this is you've got all of that wasted time of going in the liquid and out of the liquid and in the liquid the whole time. This printer actually flips it upside down and actually sinks its print into the liquid as it goes. I actually bought one of these. This is the one that I parted with far too much money to buy. There's a guy in Melbourne, he's in Brisbane. He's built them. They're called the Gizmo. And this technology basically allows for what's called continuous printing. So I watched The Fifth Element the other day for about the millionth time, and there's a part where they're reprinting Lilu, and they put her bones together in one go. This is basically what this machine can do. So if you've got the extra add-on, which is another $3,000, which I didn't buy, it will continuously print your parts from top to bottom in one go. And it's has really stepped up the SLA tech, which is the reason that I bought most of it, not the really expensive bit though. It's very, very cool tech. Now, where the biggest area of growth is software. So 3D scanners are really cool, but all of the ones that are really good are like $10,000, which I would rather draw it myself than buy one for that price. The 3D modeling tools are hard to use, but very cool. I did some teaching at the last BuzzConf. We built a vase out of a cube, and I know that doesn't sound awesome, but it was great. We used subsurface modifier to turn something that is square into something that is curvy and elegant, but it's very hard. So the slicing and printing stuff, I had to buy a special application that took my cool 3D model and turned it into something that the printer would understand and would actually come out with a good outcome. There's nothing like auto-config, which is when your computer knows what your printer is and they share information, have an agreement about how things work. And there's not really any software that integrates something like that Mosaic that I was talking about earlier that allows for color. I want you guys to think about who here has seen Big Hero 6? Oh, I wish there was more. It's one of the best movies ever. It's nearly as good as Shrek. There's a bit where Hiro, who's the hero, which is quite a convenient kind of name, he 3D scans his friends and his robot friend and makes them armor. Now, what I really like about it is this printer was this laser-guided thing that made carbon fiber, but you didn't see any of that. And the software was this magical stuff that just did what it did and nobody actually noticed. And I know it's fiction, but it really is where stuff is going to head towards, because for this technology to really take off, it's got to be easy for everyone to use, not just crazy geeks like me that don't sleep. So that's, I think, where the biggest growth is going to come from. And the next one area of sort of improvement for the future is education and community. So the Australian government's pouring a bunch of money into initiatives to bring 3D printing and technologies like rapid prototyping into schools, whether that be with the something called a 3D doodler, which is like a pen that you can draw your own 3D models in the air. I'm sure that would take a little while, but it would be cool. Now, I'm actually planning on building a syllabus and trying to get this into schools because it's just an excellent area for creativity. There are already a couple of really good communities online, and they're just getting better and better and better. I don't know who here has been to Thingiverse. It's a bit of a specific thing for 3D printing. But you can go on there and you can take somebody's model and you can be like, dude, I really like it, but I want to do this. And they'll say, piss off, make your own modification. You can do that. You can just create your own mod and so you reference the other guy to say he did it, but I'm doing my bit. And you can share it around. It's really cool. And Instructables, I get lost in that site. I've put Colossal there, particularly for the amount of time that I've spent starting with 3D printing and ending up with advanced crocheting, with duck beaks. It is amazing what you can get on there. They have a plan on there that I was looking at the other day that I had to stop for a 3D sintering machine, which is freaking laser beams. Really want to build that. So, yeah, it's got a lot of areas to grow, but this one I think will be what makes everybody pick it up. Once the software has got up there, the hardware is already there. Everyone getting on board and having a play is where it's going to go well. I'm not sure if I'm making the feedback. So, bit of a final word. I know I sort of talked about it like it was a bit of a dark thing. The models take ages and they break and it sucks, especially at 2 o'clock when you've got to go to work at 7. But it's really amazing. Like, it enables people to make whatever they feel they need at the time to suit the purpose for what they're doing. I saw one guy had a model for, the little artist craft knife, and it's got the lid on it that stops you cutting yourself when you pick it up. I lost that, and I started cutting myself when I picked it up. So I found a model on Thingiverse that I could just print that, which means I don't cut myself, but all of these small things. I've got it designed for the little toilet roll holders, the bit of wood that always falls off. I've got it designed for that. That's, going to be quite useful when I get around to making it. It's a really, really great thing, and especially if you're someone like me and you love making things in the real world, as well as software, obviously. Those spiders I built are filled with it. It's the only way that you can manufacture your own parts. So that's pretty much me for today. I'm not sure how fast I spoke. Oh, not a bad time. And that's Steve. Do we have any questions today? No? Steve is extremely primitive. He basically walks forwards, he walks backwards, he turns on the spot, and he smiles a lot. The next spider, which I've got parts of on the table over there, is designed to have a full AI that allows him to walk of his own accord and follow me around and say sarcastic things. But Steve is my firstborn. I'm very proud of him.